This video is on key features of a function. We're doing examples 5 and 6, functions without context. So on these problems, we have only a graph and we're asked to answer questions on it. We don't have a context of the problem, so it's not a rocket, it's not cell phones, it's just a graph. So first question says, given the graph g of x to the left, so this is g of x, please remember that g of x can be written as just a y equals. We're going to identify and describe the following. So g of 3. Understand that it used to look like g of x. So instead of it saying g of x, it says g of 3. What this really means is that the x value is 3. So if we were to write it as a coordinate, we know that the x value is 3. So the question is, we want to know what the y value is. So when the x value is 3, we need to go to the function. So if I go up, I don't hit any function. If I go down, I hit the function. It hits at this value here. Where is that on the y-axis? It's at -3. So g of -3 is equal, g of +3 is equal to -3. And what that means is that we have a coordinate of 3, -3. This is our x, this is our y. This is pronounced g of 3, not g times 3. So we're going to do the same thing for b. This says g of -5. So again, the g is there, but the x is now -5. This will be written in a coordinate of -5, comma something. So if we go to our x value of -5, I need to find the function. So if I go up, I'll hit the function. It's right here. I need to find that y value, so I go to the y-axis, it's at +5. So g of -5 is equal to +5. So the coordinate can be written as -5, 5. Part C says g of x equals 2. So we have the letter x in here. That means that we don't know the value of x. We don't actually know the value of x. We want to know when the y value, because this, we don't know x, so we must know what the y value is. For what input values will the output value be 2? So for what x will the y be 2? So we go to that y-axis of 2. And now I go left and I hit my graph. But if I went right, I also hit the graph. It's very similar to it hitting it twice. So we want to know at what point does it hit. So we have, here's a value of 2. At -4 it hits. So when x is equal to -4, and, because it does hit twice, we go from +2 over until it hits the graph, and that's at +6. And when x is equal to 6. So if we're looking at this, remember, if the x is replaced with a number, that means x is that number. If x is not replaced, that means you don't have the x, you have the y. So these are coordinates -4, 2, and 6, 2. Identify the y-intercept, which is on the y-axis. So roughly right here, we're just going to estimate that. That's going to be a coordinate of 0, comma, because we did not go left or right. The x value is 0. That's roughly -3 7/10. It is an estimate. Identify the x-intercept or intercepts. So we look for when it crosses the x-axis and it also hits twice on our x-axis. So these will be at coordinates. First one is at -3 on the x and 0 on the y. And right here, that's an x value of 5 and a y value of 0. Find the minimum. So the minimum is the lowest point on the graph. So we want to find the lowest point where it hits the lowest and then it comes back up. This is that coordinate of 1, -4. So here's our minimum point, but the minimum value is going to be the y value of this. So the coordinate is 1, -4, and the value is -4. So y equals -4. the coordinate is at 1, -4. For what interval is the function decreasing? So I'm going to get my highlighter, decreasing. So remember, it goes from left to right. This graph actually keeps going forever, but I'm just going to use this for right now. As I move on this graph, on this left-hand side, as I move to the right, I follow my graph, and it is going down right now. So I can highlight this green, and then it reaches that minimum. Then it starts going back up. So I can say that it's all of this graph. This green part would be all of this graph until it hits that minimum. And then from that minimum, it will start to increase. I'm going to highlight that, where increasing is going to be in orange. So from that minimum, it's going to keep going up, but it'll keep going up forever, so it's not going to stop. So because it's not going to stop, I'm only going to have one inequality in it. So decreasing is actually from that minimum of 1, that's my x value, but it's going to be all of the x values that are smaller than 1. It is actually decreasing, the graph is decreasing. So I know it's a little counterintuitive because it looks like it's going up, but you got to remember, it's going from left to right. So all of these numbers at -20, -15, -10, -8, -7, -6, -5, -4, -3, -2, -1, 0, 1. So everything that is less than +1. So x is less than 1. Now I'm not going to put the equal to sign anymore because it's not increasing or decreasing at 1. I'm just going to say it's everything that is smaller than 1 is where it is decreasing. But then at my 1 and everything above 1, I can say that it's increasing. So my increasing values is going to be x is greater than 1. So if we look at example 6, we're going to do some of the same information. This time, we're given the graph of f of x. It's the same type of thing as g of x, it's just a different letter in front. So it's f of x, g of x, h of x. It just really means y equals. So we're going to identify and describe the following. So f of -4. Again, the x is being replaced with -4. So that is, for a coordinate, that'd be -4, comma something. We've got to find that y value. So if we go to the x value of -4, we're going to find the y coordinate of that on our function. That looks to be at -3. So f of -4 is equal to -3, so the coordinate would be -4, -3. For b, it says f of 5. Again, this is the x value is 5, so we find the y value when x is 5. So x is 5 here. We're going to go up until we hit the function. That looks to be at about 1.5. So our coordinate is 5, 1.5. So f of 5 is equal to 1.5. On C, it's asking f of x equals 1. Again, we don't have the number for x. That means that that's what we're looking for. The 1 is the y coordinate. So we want to find when y is 1, so we go to 1 on the y-axis, and we go to our function. Nothing on the left, we go to the right, and we hit our function. That looks to be at about a +4. So we can say that x is equal to 4. So on D, same thing. F of x, we don't know what the x is, but we know what the y is, -4. So we know that this will be a coordinate with a y value of -4. We need to find the x. So if we go to the y-axis to -4, we follow our function, so we don't go right, we'll go left, we'll hit our function, we will know that x value, that looks to be at -6. So x is equal to -6. Our coordinate would be -6, -4. Identify the y-intercept. Our y-intercept is where it crosses the y-axis. The x value is 0, the y value is -1. So it would be 0, -1. Identify the x-intercept or intercepts. When does the graph cross the x-axis? So here's our x-axis. It doesn't cross anywhere except for this one location. So this is at the x value of 2 and the y value of 0. It is a coordinate. So for what interval is the function decreasing and then increasing? So decreasing, I'm going to have in green. And then increasing, I'm going to have an orange. So we're starting from the farthest left point, which is an arrow. That means it does go on forever. But this is going to help us know that this is kind of where it's starting from. So as I move to the right, my graph is going to go up. I'm moving up, 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 and it never comes back down. So actually, I can highlight all of this in orange. There will be no green. There will be no decreasing. So for what interval is it decreasing? Never. It never decreases. So what interval is the function increasing? Well, because the arrows are they're not points, they're not starting and stopping, these will actually go on forever. So we can say it is always increasing. Now, to write this in correct notation, we could say all real numbers. That's one way of putting it. And then the all real numbers, there's a symbol for this. We could say x is equal to this fancy R. It's 2 lines, and you make the R part starting in the back, in the first vertical line, making the R to the second line, and then coming down. That's the fancy R. That's how we write all real numbers.